Okay, so for all these problems, we're basically going to solve for x. So on number 1, I wrote the problem one time, and then we'll work on the second one. That way you know what the original problem was. All right, we want to get, the first thing to do is to eliminate the denominator. Okay, so we'll eliminate that denominator. To do that, to get rid of the fractions, because sometimes it's called fraction buster, I need to multiply by the least common denominator, which is 4. So what I'm going to do, see the 4 right there? I'm going to do is multiply every term by 4. Because whatever you do to one term, you got to do to all of them. So I'm going to multiply this times 4, this times 4, and this times 4. Okay, so I'm going to multiply by 4, and I'll put that right there. That way I'll know for the future. Okay, and if I do that, 4 times 3 is 12, so this is 12x. And then notice on this one here, 4 goes into 4 once. So it's like it cancels out. That's why we did that, to get rid of that denominator. And you're just left with 1 times 3, or 3. And then I have 5 times 4, and that's 20. Okay, now we're down to a simple two-step problem, which many of you are very good at this. You can probably do it in your heads. First step is get rid of that constant. So I'll do the opposite. So I'll add 3, excuse me. And that gives me 12x. And I'm just going to write that over here. Add 3. And this is gone. 20 and 3 is 23. You know what? Doesn't look like it's going to be a very neat answer here. So next I want to go ahead and divide by 12 to get rid of that 12. I'm going to write that over here. Divide by 12. And what happens is that's gone. And you're left with x. And over here, that's your answer right there. 23 over 12. We'll just leave it an improper fraction. Okay, number 2, same type of problem. Remember, you want to get rid of that denominator, so there's no fractions. So to get rid of that 2, we're going to have to multiply everything by 2. So multiply everything by 2. Multiply this term by 2, this term by 2, and this other one. All right, so let's see now. We have, excuse me a minute, 2 times 5, that's 10. And these 2 reduces, right? Just reduce to 1. 1 times 1 is 1. Then I have 14 times 2, that's 28. Okay, next step is to, well, now a two-step problem, get rid of the minus 1, the constant, so I'll add 1. I'm going to write that over here by steps. So I'm going to add 1. Okay, and if I do that, that's gone. I have 10x equals 28 plus 1 is 29. Okay, doesn't look like it's going to be a nice, neat fraction here. So next step, I want the x by itself, so get rid of this 10. Do the opposite, I'll divide by 10. So I'll write that over here, divide by 10. And the answer comes out to be x equals that answer right there, 29 over 10. And there we go. And so that's how we solve these with the fractions in it. Just go ahead and multiply by the denominator. Okay, number 3, we have an inequality. That's a greater than, more than. So just a two-step problem. So let's see, I'm going to get rid of the minus 8, so I'll add 8. All right, that's going to give me 3x. Now I'm going to write that over here that I added 8. That's gone. And I didn't divide or multiply by negative, so my arrow is going to stay the same. And now these are different signs, so you have to subtract them. The answer is going to be negative because there's more negative. But you just subtract it, and that's going to give me 21. All right. Next step is to, again, we want the letter by itself, variable. So I divide by 3, both sides. And if I do that, I end up with, I better write that down here before I forget. I'm going to divide by 3. And if I do that, I end up with, excuse me, x. Now, I didn't divide by negative on both sides or multiply by negative. Okay, I didn't do that to both sides. So my arrow is going to stay the same. And 3 goes into 21 7 times, and there's 1 negative. So there's the answer right there. Now to graph that, let's see, it's negative 7. So I'm going to put a negative 7 here. And remember, if x is on the left side, just go with the arrow. If the arrow is pointing to the right, then shade to the right. But first of all, is this an open or a closed circle? Now there's no bar. There's no bar, so it's an open circle because we're not talking about negative 7. It's not including negative 7. And then just shade with the arrows because we're talking everything more than negative 7. Well, these numbers are all more than negative 7. Right? X is more than negative 7. Well, these are more than negative 7. But not negative 7, but more than. Okay, sliding over number 4, same type of problem. Inequality, it's just a 2-step. So first step is to get rid of the constant. So I'm going to do the opposite. I'm going to add 12. And so I'm adding, I'll write that down here, add 12. Okay, and that's going to leave me, this is gone. That gives me with 4x. I didn't multiply or divide by negative. These are different signs, so you have to subtract. There's more negative, so it's going to be negative. Now I subtract it, and I'm going to end up with 24. Negative 24. All right, next I want to get the x by itself, so I'll divide by 4. And that's going to leave me with x. I didn't use a negative on both sides there. I didn't divide or multiply by negative, so the arrow's the same. 4 goes into 24 6 times, and there's 1 negative, so it's negative. Okay, so if we graph that, okay, we're at negative 6 this time. That's about right there. We'll just say there. And this is also open, so we'll make that open. Right? There's no bar, so it's not negative 6, but it's more than negative 6. So that's going this way. All these numbers are more than negative 6. And you just go with the arrow. Since x is on the left, go with the arrow. Okay, number 5 is a similar problem. Inequality. So let's first get rid of the constant. Do the opposite. I'll subtract 9. I'll write that step right here. Subtract 9. Okay, and that's going to give, that's gone. That you have 4x. I did not multiply or divide by negative, so the arrow stays the same. And these are different. Well, I just subtract. 53 minus 9. So if you have to borrow in your head, that's okay. So that gives us 4. So that gives us 44. All right, now you should be able to see the answer. Okay, but if you did not, if you could not see the answer, then you simply divide by 4, right? Get the x by itself. And that's gone. And that's going to leave us with x less than, because I didn't use a negative on both sides. I didn't divide or multiply. And that goes in there 11 times. Okay, there's your answer. So now what we need to do is graph that. Well, let's see. It's 6 times 3 is 12. 6 times 3 is 24. 24 times 3 is 48. 48 times 3 is 120. 120 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 times 3 is 120. 1 it's at 11. Well, that's over. Let's just say that's over here, 11. And it is no bar, so it's an open circle. And it's x is everything less than 11. Well, this is less than, it's going this way. And notice how it's going with the arrow. I'm shading with the arrow. As long as x is on the left, shade with the arrow. Okay, number 6, similar problem. I'm going to go ahead and subtract 7, both sides. Get rid of the constant first. That's gone. It's 5x. I'm going to write that step down. Subtract 7. Arrow stays the same. 32 minus 7. If you need to borrow, go ahead and do that. Okay, you should be able to see your answer right now, but if you cannot, you would simply divide by 5. Okay, arrow stays the same. 5 goes in there 5 times, so I just divided by 5. That's gone, and here's your answer. So I need to graph that. Excuse me. So let's see, we're at 5. Again, there's no bar, so it's open. And it's less than, x is less than 5. Well, that's all these numbers here are less than 5. All these numbers, and it keeps on going. So we're just displaying the answers here. We're graphing the answers.